With this device, we will see the energy losses in pipes. As you see, different type of pipes connections. So, for example, major losses and minor losses. And for example, for major losses, we have two type of pipes. This is thick one and thinner one. So we will show how losses occurs in these two type of pipes. As you see, there are two connections here, and by using our piezometer pipes, we can measure the pressure with these two parts by connection of those pipes. And then we can observe from piezometers some pressure values of these parts. So after differencing our the different pressure difference, observing pressure difference, we can find the energy losses between those two parts of the pipe. So also here, thinner pipe, we can find all these connections. We can find the pressures, and then we can observe the minor and major losses in all pipe connections. As you see here, there is a pipe separation. Water is coming from this way, and it will separate. And here there are combination and 45-degree combination, as you see. And these are, you observe 90-degree elbow, and here 45-degree elbow. And here also sudden enlargement, you see, from thinner pipe to thicker pipe transition. And here also from thicker pipe to thinner pipe, there is a sudden contraction. Also, you can observe the pressure change by connecting the piezometer pipes to here. And also we will combine this device to hydraulic bench. Hydraulic bench is here. This will provide the water to the system. Also, we can measure the discharge by using this hydraulic bench. And we use this device. This is an open channel flow model. And by using this, we can do some kind of open channel flows simulations, and using different types of weighers, for example, or some different type of gates, for example, slice gates or radial gates. We can observe their working principles. So here I will show there is a tank. We get water from this tank, and here there is a open close button of pump, and switch on switch off, an emergency button here. And this is rotameter, and rotameter to measure the discharge or flow rate. And water will come from this pipe, you see, to here, and then from this reservoir will continue by this way, and then come back to reservoir. So by this way we can observe the open channel flow, and this is approximately 2.5 meter length. And I want to show you some apparatus for to do experiments in open channel flow. For example, here there is a OG profile. This is OG profile weigher. We will locate this against the water, and then observe water flow top of this wire, from top of this wire. Also, this is another OG profile wire. You see, the difference is there is a sky jump here. So water will come from this way and will jump by using this part to prevent destruction effect of water to this ground. So another type of wire here, broad wire here. This is also used for getting uniform flow over the wire. So another parts, or I can show this. This is slice gate. This is slice gate, and we can adjust gate opening or gauge opening depth. We can adjust by using these buttons, and so we can also measure the depth of the gate by using this meter. And here also another type of gate. You see, this is radial gate. You see here. So by using this, you can adjust. So we will use also this in the open channel flow device. And also here you will see another type of wire. This is siphon wire. Also we will do an experiment by this part, and we will observe how siphon wire works. And also here you see wire air vent, so we can add air to the siphon by using this apparatus. And so we will also do this experiment. And another apparatus is this OG profile wire, and also this energy dissipation structure. You see here there is a short blocks and some rectangular blocks. All these are used for energy dissipation. Also here you see long seal and short seal. Also we can fix these to this energy dissipation structure. So the other type of wire, you see sharp crusted wire, and this is a triangular shape, you see. And also we have other types of other shapes also for this. For example, this is rectangular, and this is as you see, this is trapezoidal shape. We can fix them to here to obtain different types of sharp crusted wires. Here there is another device. You see, we use this for flow measurement. Also we will use this by combining these two hydraulic bench, as I showed before. Here there are some manometers, you see, to measure pressures. And here there is a flow measuring section, pitot tube, which says pitot tube, and also venturi nozzle. Here you see, you can see the section. There is a large section, and then so narrowing here, and here there is a rotometer again to measure or observe the flow rate or discharge. and flow is coming from this section to here, and this from this to tank, hydraulic bench tank. So we can also measure discharge by using hydraulic bench. So by using this device, we will measure the flow rate in the system. Water will come from this to there and follow this way, and then we'll come back to reservoir. So we can measure flow rate or discharge by using pitot tube and using venturi nozzle, and we can observe using rotameter, and also we can measure by using hydraulic benchmark. So we can compare and we can add some comments, make some comments for these comparison or for these different discharges to see the differences. So how can we measure discharge by using this device? As you see, there are two different parts here, and we can measure pressures from here, and from here, as you see, we can measure total pressure, because also velocity or dynamic pressure also can be measured by using this, and this only will measure only static pressure. So by the difference we can calculate the velocity of the system. So also we know the section area of this part, so from them we can easily calculate discharge. Also by observing venturi, by using venturi nozzle, any two sections we can select and then apply Bernoulli equation, and we know the pressure in two sections, and also we know the area, section area, so we can easily calculate the velocity and also flow rate of the system by using this venturi nozzle. And also with that we can directly observe the discharge from this rotameter. So we can do all these experiments by using this device. This device is used to do experiment using centrifugal pump. So here you can see centrifugal pump there, and this is combined with hydraulic bench. Hydraulic bench is used to provide water to the system, and here pump open close button, pump, and switch on, switch off. This is for hydraulic bench pump. Don't confuse with the centrifugal pump. You see there are two pumps, so that's for hydraulic bench to pump the water to the system. So here there are some buttons you see. This is open close for centrifugal pump, and also switch on, switch off. And this you can see the speed of pump using this button, and here there are some monitors. This shows the speed of the pump, and minus minutes, so 1/minutes, or revolution we can say, RPM we can say. So this shows the power of the pump. And so here there is a manometer. You see there are two manometers. One is inlet for measuring inlet pressure, and this is outlet pressure. And also you can see there is a ball valve here. By using this ball we can adjust water we want to pump, amount of water, and also by changing this valve we can observe the outlet pressure of the pump. So by this way, we can measure the head of pump, so efficiency on pump, and the relationship between discharge and uh, so discharge and efficiency of pump, and discharge and head of pump. So there are different relationships we can obtain by using this device. And this is another device. This device is used to measure cavitation or observe the cavitation, and how cavitation occurs and how it affects, and also its destruction effect, or you can observe something about, or you can get an idea about cavitation after this experiment. So there is a tank, is a water tank is here, and here you see to open close vein for flow rate. You can open and adjust the flow rate amount by using this. And here there are two manometers here, and this is again a pump, you see. And also here we can measure inlet pressure and outlet pressure by using these manometers. And here also again another way of valve to we can use this to measure to adjust outlet water. And there are two monitors here again. The one is for speed of pump, and other is for flow rate measurement. And also this adjust a pump, one or two, to adjust different type of pumps. And this is speed of pump. You can adjust, increase or decrease the speed of pump by using this button. Here switch on, switch off, and there is a heater here. After opening this, you can adjust the temperature, and then it heats the water. After that, you can observe the effect of temperature on cavitation. So I can say that increasing temperature increases cavitation. And also by increasing velocity, you will see that cavitation will increase, and you will hear the high sounds, high level of sounds, and all cavitation bubbles. From here you can see transparency here, transparent, so you can easily observe the cavitation bubbles there. So after this experiment, we will get an idea of on cavitation, so how it damages the parts of hydraulic structures, and it should be considered carefully considered in hydraulic structures, actually, especially in pumps or turbines or in other structures. Thank you, everybody.